Welcome. I am the amazing physicist, also known as Mr. Henner to you. Also, just want to let you know, I'm glad you're here, glad you're watching this video. I'm doing a kind of own segue introduction to this upcoming video because it ended up running a little long, and letting you know that this is your homework. So don't worry about it. The next couple of days is kind of lenient because we need to get some fundamental things down and you see what's going on. So with no further ado, I'm introducing myself, which is strange, but hey, I am strange. You've met me, right? So without further ado, this is the video. It's about ideals. It is critical thinking. It's going to go into pretty much reading comprehension and a few things, what to expect in the class, and do an example for the ideals model, which is an acronym, which you will find out momentarily. Well, without further ado, here I am, and I will see you next time in class. Okay, let's get started. So, first of all, I just want to let you know that what we're getting into is important, and it's because that you're in a math class. I know, it's the downers. I'm a physics guy, so I have to be excited about it. But that doesn't mean you have to. But if I do my job right, maybe I can get you excited about it if I do my job right. So, math is descriptive. It describes things. It is not inherent. Therefore, you have physics and chemistry and biology and engineering and electronics engineering, and math describes all these things. As a physicist, I can tell you that math is highly important to even the cell phone you may be watching this video on. And I'm glad you're here because that's the first step to success. If you're looking at me right now, you've taken the first step. So here's the thing. Math describes things like chemistry, and math is kind of beautiful in its own way because in of itself, it is the only thing that can actually be proven with a moderate amount of absolute. In the science realm, absolutes are not usually a thing that scientists deal with. But math, that's about the only place you're going to have a proof that it's completely proven. Like you can find papers about 1 + 1 = 2. I would not suggest you read them. I have. It's not a fun read, but it exists and it does prove it. It's great for physics. I'm a little biased. I can't help it. But here's the thing. We're going to move into something else here. And when it comes to math and chemistry and all these different subjects, one of the greatest things you need to learn about is critical thinking. You need critical thinking skills. And you use critical thinking skills all the time, whether you know you use it or not. When you walk into an ice cream shop, you're using critical thinking skills. It may not be really important, or maybe it is. Maybe you're lactose intolerant. Maybe you're allergic to peanut butter. But you look at things and you make decisions based on your previous knowledge that you're bringing into the situation, and then you're making a decision based on what is presented in front of you. So the first thing about it is critical thinking is just objective analysis of a situation. The long form I won't get into, but the quick and easy is the objective analysis and evaluation of an issue in order to form a judgment. That is critical thinking. And there's 4 parts. There's many more, but we can condense it into 4 parts. The 4 parts are knowledge. It's what do I already have? What do I already know? So when you're looking at a problem in physics or math, or whether it's a problem like the ice cream shop, you want to know what kind of ice cream you want, what kind of sundae, what's going to go good together. Nope, I don't want the little shriveled up grapes on my sundae. Because I know from previous experiences I don't like raisins. So there's a simple part of knowledge that you're bringing to the table. Another thing is understanding. So do I know in general what is needed to solve or come to a conclusion on what I'm trying to do? And that's just something you do without even really thinking about it. No pun intended. One thing is making inferences, and I want to be clear on this. Inference and assumption is not the same thing. An inference is what we already know from what the problem is giving us, or combining what the problem is giving us, what it's telling us, like being in the ice cream shop, with my own previous experience. So I can infer if I'm allergic to peanut butter, and there is a chocolate mocha Happy Doodle shake, and I notice that it says may contain peanuts, I can infer that I may have an allergic reaction to that sundae and should not buy that sundae. So that's an inference. Made a judgment based on information presented to me that I noticed and what I already knew coming in. And all of this leads to synthesis. You synthesize the information, and that's just bringing this information together to come to a conclusion. So you decide to get the strawberry fluff tart sundae. Yeah, sorry, I'm not great at making up names for sundaes. You give me some ideas. But so another thing that most students don't realize is that reading, comprehension is very important. And what a lot of people, and I hate to use generalizations, but what people tend to not think about is that reading comprehension is not just about reading Shakespeare or reading the book in your comp class or reading. Are you playing an RPG? Are you reading the text? I love RPGs. Just a random thing there. JRPGs too. The point is that reading is a part of your life every day. You always have to read. Nobody's ever. If anybody looks at you and says, "I don't ever need to know how to read," well, no, you need to make a correction on that because you read things all the time. It can be for fun. It could be for business. It could be for your job. It can be for school. Reading comprehension is important. And one thing that people don't realize usually is it can be even like with math or physics. It can be a model. It could be a bar graph. I'm sure many of you have read a bar graph. It could be, let's think, I don't know, a pie chart. A comparison graph. Flow chart. Very important. A lot of people struggle with those. Flowcharts are important too, especially in electronics, believe it or not, but that's another subject. Once again, one of my biases. I love electronics. I hope you do too because you got a phone in your hand, and I'm sure some of you play video games on PlayStation 4 or Xbox or, the Switch. All part of electronics engineering. All has math in it. So think math. One that you probably didn't think about is that reading comprehension can be important to your health. If you're a health conscious person, labels may be something you want to make sure that you know how to read and don't misread. Especially maybe you want to make sure that there's certain ingredients that aren't in something, or you're on a diet, or you're trying to gain weight, or whatever it may be. So reading comprehension is important. As we go through the semester, you will be given text to read, and I don't mean books. I'm not going to assign a book to you. This is a math class. I'm talking about little snippets of information that's going to help you build vocabulary because vocabulary is important. One of the keys to critical thinking and what we're getting to, this ideals that I'm leading up to, is you have to be able to comprehend what you're reading, or you're going to make wrong inferences. You're going to draw conclusions that aren't there, and you're not going to understand the problem. So that's important. So reading comprehension is very important for critical thinking when you're analyzing a word problem. And I know all of you love word problems because I know that's my favorite. I'm kidding. I know. But I'm going to teach you a way to do it that makes it a little easier. And at first it may seem silly because if you're just trying to figure out 2 + 2 = 4, this is a little bit long method. But if you're trying to read a word problem, this is very useful. And we're going to start off with a simple one first. Now this is probably a something you do in 6th or 7th grade. This is not a difficult problem. Most of you are going to look at this and be like, well, duh. Some of you may not. It's no big deal. It's just according to what experience you're bringing. What is your knowledge you're already bringing? And once again, I'm going to show you how inferences, vocabulary, and everything plays a role into solving this problem. So first, the acronym of the day, ideals. Let's start with the first one, identify. So when you've got a problem, you've got to identify what question you are facing. So let's take a look at our question for today. Let me give you a read. So there are 22 bicycles and 30 cars in the garage at Christina's apartment building. Man, that's got to be on Celebrity Cribs. That is one huge. Maybe, yeah. Anyway, how many wheels are there in the garage? So, I'm assuming she lives in just a regular apartment building. I was thinking more of like a condo. But, so first thing we need to think of is, what's the question? Well, the question, just to highlight it here, is how many wheels are there in the garage? So that was the first step. We have identified what we need to. Identify is the easy one. Sometimes it's not. Sometimes identify can be the one that's the hardest because the questions can get a little bit more complex. But in this case, it did not. So we identified it. Identify, we're done. So what we can do is say, okay, we know that we need to know how many wheels are in the garage. So moving on. I don't have to stay around too long. The second one is the D, and the D stands for define. So it says basically it's what are the facts that frame this problem? Okay, let's look at it. So we know several facts here, and let's go ahead and highlight what we know. We know that there are 22 bicycles and 30 cars, and we know that they're in the garage. But we need to do something else. We need to make an inference here. And this is one where it could be an actual just assumption you have to make, which is there is a difference. But in this case, I'm going to go ahead and say this is an assumption. We need to assume something. Can you think of what maybe we need to assume? Well, we better hope there's no spare wheels lying anywhere, for one, that's not attached to a vehicle, because that's going to change our answer, isn't it? And that pretty much takes care of that. We've made sure, so we're going to just assume there's no spare tires and nobody's got spare bicycle or car wheels anywhere. So next we need to define what is a car. So we need to define what is a car. So how many wheels does a car have? Well, we know that most cars or trucks or ATVs have 4 wheels. Now, the define part is important in this problem because of this right here. And this is where vocabulary comes in. So you have the word by. Usually, by means to. So that's why it's called a bicycle. Now, from inferences or previous experience, you may come in and say, well, I already know what a bicycle, how many tires it has, because I've ridden it. I know what they are. I've rode them. Okay. If you've never seen a bicycle somehow, then if you know vocabulary, then you would know that by means to. So we have defined what we need to define. And now we go on to the next part, which is E, which pretty simple, because we've really, with this problem, already done most of the work, and we need to enumerate. And to enumerate, we need to know what the plausible options are. Well, unless some of the cars in there have had a flat tire and on the middle of them being, the tire replaced, we know that the cars have 4 tires, and we know the bicycles, that they have 2 tires. I'd like to pardon my writing. So that right there is what we need for the enumerate, or the first part of the enumerate. And now we just need to know how many cars do we have. Well, we know that we'll say C is equal to cars, and we have 30 cars. And we'll say that B is equal to 22 because we have 22 bicycles. So we've set up the problem with enumerate. And there's our 2 things that we know, right? Should say wheels. There you go. So you can see that we're starting to get there. Now we need to analyze. What is the next best course of action? Well, what we do here is we take the data we've got, which we already know. We've got 22 bicycles, so we take all the data we have. Remember, we've got 22 bicycles. We've got 30 cars, right? All right, and we know that the bicycles have 2 tires or 2 wheels, and that the cars have 4. And we need to make sure we find out what altogether, how many wheels in total we have. So we can set up something like a linear equation. Now, if you're in 6th grade, you probably wouldn't use a linear equation, but I know you guys have seen linear equations and you know about this. So I'm going to set a really simple one up. And this is where we analyze. This is where we solve the problem. So we have 22 bicycles. And then we know we have, 30 cars. So, and we know that equals the total wheels that we have. And this script here, just as a little education, T sub W, that just means total wheels. It's called a subscript. Don't let that confuse you. It's a math thing. It's something I will teach you. You will learn sub and superscripts. They're simple. They're just ways of abbreviating things in math so you don't get confused. Especially if you're dealing with Z or a different letter. You confuse your Z for a 2 and your 2 for a Z, and well, you end up not getting an A on the exam. Not that I've ever done that. But anyway, so now we've got 22B plus 30C equals T sub W. So we now say, oh, well, we know that a bicycle has 2 wheels. We know that a car has 4. So now we can just substitute this in, 22, and just say that's 2. Plus we have 30. And we know that's times 4. And that's going to equal total wheels. Well, we say now we got to pull out something from the past that we know. Everything builds on itself. Now this may seem obvious to some, not to others. Remember, PEMDAS, we got to make sure that we multiply first, and then we add. So 22 times 2, simple enough, right? 44. Everybody in agreement? Hope so, because can't hear you. Plus, so 30 times 4, 120. Once again, everybody I hope's in agreement. And then we have equals TW. And then, of course, if you add these together, you're going to get your total wheels is equal to 164. Making sure I do that right in my head. So we've solved our problem. Now you say, well, Mr. Henry, what's left? Well, there's another thing you can do called list. That's the last. Now, I'm going to tell you this. This is where it gets interesting. So, in this type of problem, listing is not going to be important because we know that there's only like one or two ways to do this. And really, this is the only one off the top of my head I can think to do this. Or you could skip all those steps, just be like, well, it's 22 times 2 plus 30 times 4 equals, and you just skip it. But when you get into different subjects of mathematics and you're solving things that are more complex, even if it's not a word problem, list will come in to play. Because there may be 5 or 6 different ways for you to solve the problem. And there may be one that's more reasonable or maybe a shorter time. And by listing out the different ways, after you're done that you think, well, I could have done it this way, or wait, now looking back, I could have done this, you learn. And you say, well, next time I'm going to try it the other way. And you may save yourself time on a test or a quiz or on the ACT, a ways off from now, which is very important. And it all comes back. Every one of these 6 letters of this acronym will help you. So once you list, which I will just say, that's the only way, so we're good, right? If you have other ways, let me know in class. If you have other ways that has a different order or progression, because I want to know, because off the top of my head I just can't think of another way. All our brains work different, so your classmates may come up with different ways of doing things than you do. I can guarantee you they will. So the last part, and this I cannot stress enough, guys, I cannot count the number of times that I have kicked myself in college because I did not check my answer when I got to the end. And in this case, really, you could go back, and if you wanted to self-check this, you could just go in reverse. You could just take everything and try to go in reverse, but this doesn't have enough steps to really have a self-check method. But self-correct the step is important. And what it basically is that what you want to do is if you get to the end of a problem and you get an answer, go back and see if there's either a way to plug it back in to see if it's correct. Because if you solve a linear equation, right? If I solve, the linear equation 3 plus x equals, 5, and I get, somehow x equals, 4, and I go back and I plug it in and I say, let's make sure it's right. Well, 7 does not equal 5. Try again. I can go back and I can try again. And that's the same thing here. Here, not as much. Here, you want to ask yourself, does my number make sense? And in this case, yeah, it makes sense. If it was 1,000 or 500 and some, you might think, that's a little high. Maybe I've made an error in my multiplication, or maybe I hit the wrong button on my calculator, or what have you. Like in division, if you're dividing something by something else, and the answer you get is bigger than what you started with, then you may have a problem. And I don't mean like dividing 2 into 30. Yeah, it's going to go 15 times. I'm talking about if you end up with something that's just nonsensical, and all that means it just doesn't make any sense. In other words, if I do long division and divide 4 into 100, and I get it going in 125 times, I've made an error because that doesn't make sense, right? How can 4 go into 100 more than 100 is? So just keep that in mind. And basically the last thing I want to leave you with is, hold on, let me get myself full screen and I'll tell you. I hope you enjoyed the previous lecture. He's quite great, isn't he? No, I'm joking. I hope you. I know it ran a little long, guys, and I wanted to just elaborate a little bit to let you know. We don't typically think of reading and critical thinking and all that and lumped into one, but I hope this video helped you a little bit. I know it was a little slow. Some of you may have gotten a little bored, but I have to make sure that I'm slow, so everything I say it's synthesized up here, so I have to go slow with it the first time. But that was your homework. The only other thing you need to do is fill out that poll that was on my website. Please do that, because that'll help me know your interest and hobbies and things. And if I don't know your interest in hobbies, I can't make the class exciting. I need to be able to find a way to make math fun, and it's no small feat. I mean, give Mr. Henry a break here. Give me some information on what you like. I will find a way to connect math to it. I promise you I will. But until next time, I am the amazing physicist, also known as Mr. Henry. Question everything and always think critically. Have a good day.